Hello, I am Hemant Kumar, registration number 21 PME 1122. This is the Digital Assignment 3 for Thermal Engineering Systems PowerPoint presentation about heat transfer. Today I am going to explain heat transfer. This PPT is under Professor Dr. P. Tamil Selvam. First, we will see what is heat transfer. Heat transfer refers to a process of energy transfer from one medium to another as a result of temperature difference. In many applications, heat transfer is essential to maintain proper operation of systems. Heat transfer systems are used in a wide range of industrial processes, including power generation, chemical processing, refrigeration, and air conditioning, and some types of manufacturing processes. Heat transfer always occurs from high temperature to lower temperature. Heat transfer system can be classified into three categories: conduction, convection, and radiation. Conduction refers to heat transfer through a solid material, while convection involves heat transfer through a fluid, liquid, or gas. Whereas radiation involves the transfer of heat through electromagnetic waves. Now we'll see convection. Conduction is a transfer of heat through a material without any motion of a material itself. In this process, heat energy is passed from one molecule to next molecule through a material without any sufficient chance change in position of the molecule. Metals are known to be good conductors of heat because they have loosely bound electrons that can transfer heat quickly from one end of the metal to the other. Insulators, on the other hand, are poor conductors of heat because they have tiny bound electrons that do not allow for easy heat transfer. There are many types of application for on conduction. Thermal insulation. Conduction is used in thermal insulation to prevent heat transfer. Insulators like fiberglass and foam are used in the walls and ceiling of buildings to reduce heat loss. The effectiveness of insulation is measured by its thermal resistance, which is commonly known as R value. The higher the R value of an insulation material, the greater its resistance to heat transfer. Thermal insulation is essential in building appliances and industrial processes to improve energy efficiency, reduce energy consumption, and lower operation cost. Insulation also helps in maintaining a comfortable indoor environment by preventing heat loss in the winter and heat gain in the summer. Now we'll see convection. Convection refers to a process of heat transfer through a fluid, such as gas or liquid, where hot fluid rises and cold fluid sinks. This is due to the fact that heated fluid becomes less dense and therefore rises, while cooler fluid becomes denser and sinks. The process can be observed in many natural phenomena, such as formation of cloud, ocean current, and the movement of air in the atmosphere. One example of application of convection is in the heating and cooling of building using HVAC, heating, ventilation, and air conditioning systems. HVAC systems use convection to circulate hot or cold air throughout a building to maintain a comfortable indoor. Temperature. During the heating season, this HVAC system draws in cool air from the outside, heats it up and using a furnace, and then uses a fan to circulate the warm air throughout the building. As the warm air is circulated, it rises to the ceiling and it is replaced by the cooler air, creating a convection current that keeps the room warm. During the cooling season, the process is reversed. The HVAC system draws in warm air from the outside, cools it down using a refrigerant, and then using a fan to circulate the cool air throughout the building. As the cool air is circulated, it sinks to the floor and is replaced by warmer air, creating a convection current that keeps the room cool. Now we'll see what is radiation. Radiation refers to a transfer of heat energy by electromagnetic waves that are emitted by a surface due to its temperature. When a surface is heated, it emits thermal radiation in the form of electromagnetic waves that can be observed by other subsurfaces or objects. This transfer of heat generation by radiation is independent of any material medium and can occur in vacuum. In thermal engineering, the transfer of heat by radiation is often described using the Stephen-Boltzmann law, which states that the rate of thermal radiation emitted by a surface is proportional to the fourth power of its absolute temperature. This law can be used to calculate the amount of heat transfer by radiation between two surfaces of different temperatures, as well as to design and optimize thermal systems that rely on radiation or heat transfer. Radiation has many applications in thermal engineering systems, some of which includes thermal heating and cooling. Radiant heating systems use thermal radiation to heat spaces such as floors or walls by emitting infrared radiation. These systems are often used for indoor heating and can be more energy efficient than traditional forced air system. Solar energy. Solar thermal systems use radiation from the sun to heat water or air for use in space heating, hot water or electricity generation. Solar radiation can be captured and converted into thermal energy using solar collectors, which absorb the radiation and transfer the heat of the fluid. These were the three types of heat transfer which are part of thermal engineering systems. Thank you.